Welcome back to the Marcus Maths YouTube video. We have a great video today. We're going to be going over a little bit more difficult questions in relations to differentiation. As we're moving on to Unit 3, it's going to get a little bit more complex. We're going to do a little bit more complex operations. Make sure to like and subscribe if you haven't already. And let's proceed with these 5 questions in quiz number 1. Okay, so first question, we have our derivatives and our regular functions for these two values. Let f be defined as this, capital F. So what we're going to do, we're going to find the derivative of this composite function. So when we're dealing with derivatives of composite functions, we're simply going to take the derivative of the outside function with the inside function inside of it times the derivative of the inside function. So this is also known as the chain rule, and how that looks like is this. We're going to now have the derivative of f of g of x, regular g of x, not an apostrophe. So we have the derivative of f, and g of x is still the inner function, and then times the derivative of the inner function. So derivative of the outer function, and then with the inner function times derivative of the inner function. This is how the chain rule looks. This is how we're going to use composite functions, and this is equal to the derivative of capital 4. Now, to find out at 4, we're simply going to substitute 4 out for each of our x's. So we're going to find g of 4, and we're going to find g to the derivative of 4. So that we're going to substitute out here. G of 4 is equal to negative 2. So now we're going to find f, the derivative of f at negative 2. We're going to multiply that by the derivative of g at positive 4. And now we're going to find the derivative of g at positive 4 is equal to 8. Derivative of f at negative 2 is 1. So we do 1 times 8. And we are left with 8. So 8 is the answer. Okay, moving on to the next question. We have just a simple one here. We are going to notice that we have an outer function and an inner function here. Notice our outer function is x to the power of 2 over 3. Then our inner function is our polynomial here. So we're going to use exactly what we learned in that previous question. Derivative of the outer function, inner function, times derivative of the inner function. So let's do this. Derivative of the outer function is going to be 2/3. And then we're going to subtract 1. So, and inside the parentheses is going to remain the same, of course. So we have 2/3 on the outside. Our inside remains the exact same, minus 6x. And now our outside is 2/3 minus 1, which is negative 1 over 3. Which means we're going to move the whole parentheses to the denominator, and we're going to take the cube root of it. And then we're going to multiply this with the derivative of inside of the parentheses, which is going to be 6x squared plus 2x minus 6. Alright, so now we are going to substitute in 2. Let's do this. So when we substitute in 2 to the parentheses here, we have 8 times 2, which is 16, plus 4 minus 12. 16 plus 4 is 20, minus 12 is 8. So we have 8 inside the parentheses. We're going to find the cube root of 8. We're going to put that on the denominator. So we have 2 over 3 times 1 over 2. Cube root of 8 is 2. And then we're going to multiply this with this expression right here. Let's solve out this expression. Substitute in 2. 2 squared is 4 times 6 is 24. And then we're going to add 4, and then we're going to subtract 6. So that leaves us with 22. So we're going to multiply this with 22 as well. 22 times 1/2 is 11. So we just do 11 times 2 over 3. And we are left with 22 over 3. So the correct answer is answer choice C. So all of these using the chain rule so far. We're, notice composite function. W is outside. U is inside. Okay, is this a composite function? If so, what is the inner and outer functions? Yep, we need to know that this is to the power of 9. All we need to know is that with these notations, when we have exponents and trigonometric functions, we need to rewrite as cosine of x, and then we can power of 9 our answer. Just as like if we would solve cosine squared x, you find the cosine value and then you just square it at the end. So we can just rewrite it like this, and then it becomes a lot clearer that we have an outside function with the x to the power of 9, and then we have our inside function, which is our cosine of x, and that matches answer choice A. So it is indeed composite. Inner function is cosine of x, outer function is x to the power of 9. Okay. On to our next one. We're going to use our chain rule once again. Now that we've remembered it, outside function is going to be x to the power of 3. So we're going to find the derivative of that, which is 3 x to the power of 2. But it's not x, it's just our inside function, which is cosine of x to the power of 2. So cosine squared of x. And then we're going to multiply by the derivative of the inside derivative of cosine. If we remember, it is negative sine of x. So we're left with this expression, negative 3 sine of x cosine squared of x. C is indeed the correct answer here. We don't have to do any more simplification. And as we know, these parentheses are irrelevant. And then negative times 3 is negative 3, and we move the sine x in front of the cosine squared of x because we can just rearrange these terms. Okay, that is the correct answer with question number 4. Let's move on to question number 5. We have another chain rule here. So let's just quickly write it out. We're going to find the derivative of g of our h of x inside function like normal. And then we're going to multiply by the derivative of the inside. And now let's replace our x with 0. So we're going to find h of 0 and then the derivative of h at 0. All right. H of 0 is equal to negative 3. So we're going to find the derivative of g at negative 3. We're going to multiply that with the derivative of h at 0. Derivative of h at 0 is 3, so we're going to multiply derivative of g at negative 3 with 3. Derivative of g at negative 3 is negative 7. So we do negative 7 times 3. That's equal to negative 21. So the derivative of capital F at 0 is equal to negative 21. That is the last correct answer. So this was all about chain rule, using it in different contexts, determining if some are composite functions, and that's applicable to the chain rule. But we're going to see the chain rule a lot when we're dealing with more complex differentiation. So this is very important, up there with the product rule and the quotient rule that we learned last unit. If you have any questions, make sure to leave them in the comments. If not, make sure to subscribe if you haven't already. We're going to be continuing with Unit 3 this week, and I hope to see you at those videos. Have a good rest of your day. Goodbye.